Hello and welcome to homework 15 for the studies video. We're going to go through these two problems together, then we'll do one of these. You're expected to be able to do the other one. These are the ones that are going to be on your homework quiz. Okay? So on this one, we're just looking at the two differences between the two tax systems we've already talked about. The first one is progressive. So if we look at this, it says 10% for $10,000. So if I'm at $10,000, if that's the amount of money I'm making, I'm paying 10% of that in taxes. My next one is 20% for $50,000. So I go over to where I'm making $50,000, I'm paying 20% in taxes. And then finally, my high is $100,000. And at $100,000, I'm paying 30% in taxes. So at $100,000, I'm paying 30% in taxes. So as you can see by the trend of these, progressive means the more money you make, the higher percentage you pay in taxes. So the more money you make, the higher percentage you pay in taxes. Our other system, this is what we currently use in the US. The other type of system we have is a proportional system. So proportional, let's see what that looks like. If I make $10,000, I pay 20% in taxes. If I make $50,000, I still pay 20% in taxes. And if I make $100,000, I still pay 20% in taxes. So proportional means that everyone pays the same rate. No matter how much they make. Okay, I'm going to let you fill in the shape of the graph and then which system you think is more fair and why. I'm going to hop down to this problem here, which is our percentage of total ACT problems. So this one says a motel manager's costs are 24% higher this year than they had been when the room was $60. If the room's rate had increased by the same percent as the manager's cost, what would the room rate be this year? Okay, remember when we're setting these up, we always do a fraction that is the part over the total is equal to the percentage over 100. Okay, so I've got a 24%, so that's my percentage, so I know it's going to go over 100. 60 is my total here. I'm trying to find the part. Because I'm trying to find how much it increased by, that is part of the total. So once I've got my fractions set up, I'm going to cross multiply. That will give me x times 100 is 100x. And then 60 times 24. If I pop that in my calculator, I should get 1440. 60 multiplied by 24. Let me double check that because 60 times 24. Okay, it is 1440. My mental math isn't the best, so it's always good to check with the calculator. We want to get x totally by itself here. Right now 100 is right next to x. That means multiplication. To cancel out multiplication, I'm going to divide by 100 on both sides. So I get x is equal to 14.40. Okay? That is the amount that it increased by. But it didn't ask me just what it increased by. It asked what the new cost of the room would be. If I started at 60 and I increased by $14.40, I would start at 60 and add the $14.40. That's my original cost plus the increase. So 16 plus 14.40, that gives me 74.40. So my answer choice here is J. Okay? Now for the back of this homework, this is the one I told you all about where I was going to do problems 1 and 2. And that was going to be in preparation for our lesson next class period. So I'm just exposing you to the material that we're going to cover in class on Tuesday. Sorry, I had to grab an extra blank sheet of paper because I write big and I didn't give you all a ton of space. So What we're looking at here is our exponential function. We saw the difference in progressive and proportional taxes. Progressive taxes increased exponentially. Now we're going to see how these equations can model other things. So this says in an experiment, a number of fruit flies are placed in a container. The population of fruit flies, P, so we know that population represents P. That's this variable here. Increases and can be modeled by the function below, where T is the number of days. So T is the number of days. That's this little variable here, since the fruit flies were placed in the container. First one says find the number of fruit flies which were placed in the container. So that means at the beginning of the experiment, before any time has passed, how many fruit flies were in the container. Okay, well, if we're looking at this equation above, we're going to write down what we know first. We know this entire equation, P of T is equal to 12 times 3 to the power of, this is an exponent, 0.498 T. Okay, so right now in this equation, there are two things that we don't know. We need to be able to plug in something for one of them to solve for the other. The tricky part about this one is you have to figure out what it means when they were placed in the container. So at the very beginning, it means that 0 time has passed. If 0 time has passed, so at the beginning, T is equal to 0 because 0 time has passed. Okay, no amount of time has passed at the very beginning. That means for T here, we can plug in 0. So I'm going to rewrite my equation. I know P of T, so my population at time 0, is equal to 12 times 3 to the power of 0.498, and I said that I can plug in 0 for T. So that's exactly what I'm going to do on my calculator. I'm going to plug in this side of the equation exactly as I see it. So I think you can see that calculator. So I've got 12, can't see my finger, 12 times 3 to the power of, it's this little button on the left-hand side. That's our exponent button, to the power of 0.498 times 0. Okay? And when I press enter, I get 12. So I know that P of 0 is equal to 12. Another way to think about that is at the beginning of the experiment, I'll write it up here. At the beginning of the experiment, there were 12 flies in the container. Okay? Next question says find the number of fruit flies that are in the container after 6 days. So after 6 days have passed, we're going to use our same equation here from the beginning, but now we know that 6 days have passed. So that means T, or our amount of time, is equal to 6. So we're going to use this exact same equation, solve this in the exact same way. The only thing that we change is now time is equal to 6. Okay, so I'm just going to rewrite my equation. This time I have P of 6 is equal to 12 times 3 to the power of 0.498. But this time we're plugging in 6 for T because 6 days have passed. So if I go back to my calculator, plugging this in, if my calculator will wake up, I've got 12 times 3 to the power of 0.498 times 6. And I get 319, 757. So then I have P of 6 is equal to 319, 757. What that means is after 6 days, there are about 319 flies in the container. Okay? Very last one says the maximum capacity of the container is 8,000 fruit flies. Find the number of days until the container reaches its maximum capacity. So this one is asking for something slightly different. It's given us the population, and it's asking for the amount of days. So if we look back to this original equation, let's write down what we know and what we don't know. So I'm just going to take this equation and rewrite it down here. P of t is equal to 12 times 3 to the power of 0.48998t. Okay? So let's write what we do know. We know that the population is 8,000 fruit flies, and like this setup here, P is equal to our population. So I can plug in 8,000 for my population. Then it says find the number of days. So what I'm looking for is T. Okay? T is going to be the thing that I don't plug anything in for because T I don't know the value of right now. Okay? So to solve this one, I'm going to have 8,000 is equal to 12 times 3 to 0.498t. Okay? Well, the tricky thing about this one, we can't just plug this into our calculator to solve because we've got a missing variable on this side. So we're going to use a handy calculator trick to solve this one. I know I want my answer to this to be I want my result of this to be 8,000. So what I'm going to do is I'm going to use my table of values to help me do that. I'm going to go to New Document, Add Graphs, and then I'm going to type in this right-hand side of the equation. So I'm going to do 12 times 3 to the power of 0.498. I'm going to use x here instead of t because we always use x when we're plugging it into our calculator. I'm going to press Enter and then Control T to look at my table of values. Okay? I know that I want my result to be 8,000. So I'm going to scroll down until I get something that is close to 8,000. Okay? This is 8,520 in my table of values. So I'm just going to write over this table of values here. In my table of values, I had 11 and then I had 12. At 11, I had 4,930 fruit flies. At 12 weeks, I had 8,520. So I know that these are my x values. This is time. These are my y values. This is population. So what that means is the fruit flies reach 8,000 between weeks 11 and 12. So somewhere between week 11 and week 12, we pass the 8,000 mark, right? Because at the end of week 12, we're at 8,520. So between weeks 11 and 12, the container reached maximum capacity. Okay? So these problems mathematically aren't that hard if you know how to use your calculator. It's just figuring out what in the world is it asking me to solve for. Okay? So we're going to do this next one together as well. This one says a population of 200 rabbits was introduced to an island. Okay, so I know my population at the beginning is 200. 1 week later, the number of rabbits was 210. So I know at week 1, the population was 210. The number of rabbits in, so number of rabbits is in, or our population, can be modeled by this function below, where t is time in weeks since rabbits were introduced to the island. Okay, so I know that n is my population, and I know that t is time. Okay, this says find the value of b. Okay, well, I'm going to use some information it told me before to find the value of b. I know that at week 1, the population is 210. So let's plug that into my equation first. Okay, so my population is 210. I can plug that in for n because that's my population, right? So 210 is equal to 200, it's part of the equation I'm given, times B, that's what I'm looking for, to the power of T. Well, that population was 210 at week 1. So T is going to be equal to 1. Okay? From here, my goal is to get B by itself. So I'm going to get B by itself. Draw a line down my equal sign. Right now, B is being multiplied by 200. So I'm going to divide by 200 on both sides. 210. Oops, let me get back to my calculate. 210 divided by 200 is equal to a fraction, which I can convert to a decimal, of 1.05. Okay, so I get 1.05 is equal to B. So I've answered my question here. Okay, now that I know that that's the value of B, that's how I'm going to write my equation from now on. So from now on, I'm going to write my equation as NT is equal to 200 times 1.05 T. Because 1.05 is always my B value now. Okay? This says calculate the number of rabbits on the island after 10 weeks. So 10 weeks, I'll do it in blue so it's the same color. That's equal to T. So in my given equation here, for T, I'm going to plug in 10. Okay? And I can pop that right into my calculator. So I get 200 times 1.05 to the power of 10. That gives me 325.8 is what we'll round it to. So 325.8 is the population after 10 weeks. Okay, very, very last one in this section. An ecologist estimates that the island has enough food to support a maximum population of 1,000 rabbits. Okay, so we know that that's our population. Calculate the number of weeks. So that's what we don't know the value of. It takes for the rabbit population to reach this maximum. Okay, so let's plug in what we know. I know that 1,000 is my total population. So I'm going to plug that in for N. So 1,000 is equal to 200 times 1.05. That comes from my equation. That's never going to change. And then T is the one that we're looking for. Now this one's a little trickier. It's like the one we did before. I can't just plug this into my calculator because there's a variable there. So what I'm going to do instead is go to my new document, add graphs, and then I'm going to type in this side of the equation, 200 times 1.05 to the power of x. I always use x instead of any other variable. Press enter, and then Control T to look at your table of values. So Control and then the letter T to look at your table of values. We know that we want our answer to be equal to 1,000. So we're going to look at our table of values and we're going to scroll until we see something around 1,000. So I keep scrolling because I'm at 500 right now. That's not large enough. Keep scrolling. And then I get to about 1,000 here. So in this table of values, okay, I see that I have 32 and 33. At 32 weeks, my population is equal to 952 about. At 33 weeks, my population is equal to 1,064. So what that means is the number of weeks it takes to reach the maximum population of 1,000 is between 32 and 33 weeks to reach a population of 1,000. Okay? So, again, this is material that we will be covering again in class. I just wanted to try on the homework where you see the material once, so we have more time to ask questions and do practice in class. I'm going to do one more of these example problems with you, and then this one is for you to do on your own. This is one of our percent of total problems. it says Simon, I don't know how you say that, ordered graduation announcements from Announcements and Notes. Wow, what a name. He was charged $35 for his announcement and was charged 8% of that amount for shipping. So $35 was the total for his announcements, and then he was charged 8% of that amount for shipping. Okay, so let's set up our fraction first. Our total is 35. Our percent is 8, which we always write a percent out of 100. And then we don't know the part. We don't know the value of x. We don't know what 8% of 35 is yet. We're going to have to cross multiply to figure that out. So x times 100 is 100x. 35 times 8, I'm going to have to pop that in my calculator. 35 times 8 is 280. Then I need to get x by itself, so I'm going to divide by 100 on both sides. So I'll get x is equal to $2.80. Okay? So I know that's how much extra he was charged. The question is asking me how much was Simeon, whatever his name is, charged for his announcements and shipping. So the announcements were $35, and means add here, plus the amount he was charged for shipping, which we found out was $2.80. So 35 plus $2.80 is 37.8. Our correct answer is D. That is it for the homework video. Thanks to Simeon for joining us. Like and subscribe.